This video is going to cover Chapter 10, Lesson 2, and it's going to introduce you to ellipses. So first we're going to define what an ellipsis is. And our ellipses, when we go to graph them, they sort of look like an oval. So by definition, an ellipsis is the set of all points in a plane, the sum of whose distances from two fixed points is constant. Each fixed point is called the focus. Plural for that is foci of the ellipsis. So when we have our equation, we're going to see that the bigger number, that the number that's in the denominator of our equation, is going to determine which axis is the major axis. So if the bigger number is under the x squared, then the x-axis will be your major axis. If the larger number is under the y squared, then the y squared will be your major axis. We're going to have vertices at the end of the major axis, and we're going to have co-vertices at the end of the minor axis. And we're going to talk about all these parts on the next slide. So here are the standard forms of an ellipsis when we have the center at the origin, or the center at 0, 0. So when we go to look at the equations for the ellipsis, the a squared is always going to be the larger of the two numbers. So if you notice, the numerator, it's going to stay with x squared plus y squared in the top. That stays. What changes is going to be where the a squared is and the b squared. So the a squared is always going to be the larger number. So when the a squared is under the x squared, this would tell you that your major axis is the x squared. When the a squared is under the y squared, then your major axis will be the y-axis. Again, the vertices and the co-vertices are going to come from the equation. The vertices are going to come from the a squared. So they're going to come from the equation. The vertices will come from the a squared. Remember, these are at the ends of our major axis. The co-vertices are going to come from the b squared, and these are going to be the endpoints of our minor axis. The focus, and we're going to be calculating the foci, so the focus points are always going to be on the major axis. And again, the major axis is going to be whichever letter has, whichever letter has the bigger number under it. So if x squared has the larger number, major axis is the x-axis, and it would be horizontal. If the bigger number is under the y squared, then the y-axis will be the major axis, and again, it would be vertical. So your major axis, whenever you graph them, is always going to be the longer part of the graph. So notice here in my oval shape here, notice it's longer across the x-axis. So this would be having the major axis as the x-axis. So here, the x-axis is the major axis. Over here, so the a's are always going to be your vertices. So this would be a vertice, and so would this. The co-vertices are indicated where the b's are. So those would be your co-vertices. And again, your focus points, which are indicated here with the letter C, they're going to always be on the major axis. So when the larger number, or the a squared, is under the x squared, we're going to say that it's going to be horizontal, would be the major axis. When the a squared is under the y squared, or the bigger number, then we're going to say it's vertical. So this would look like it's up and down. So notice the longer part of the ellipsis goes along the y-axis. So again, the a squared gives you vertices, the b squared gives you the co-vertices. Let's try our first example. One other thing I want to bring to your attention is notice your equation must be set equal to 1. If it's not, we need to fix it, and we're going to have to do that in our first example. So here's our first equation. Notice the center of my ellipsis is going to be at the origin at 0, 0. So in order to get this 64 to equal 1, I need to divide all 3 parts of my equation by 64. Now, anytime the fraction can be reduced, you're going to reduce it. So 4 over 64 is going to simplify to 1/16. I'm not going to put the 1 on the top. I'm just going to leave it as an x squared. The y squared cannot be reduced. And then 64 over 64 is 1. Now I'm going to look at my denominators. I need to figure out which number is bigger, 16 or 64. So I can see that the 64 is the bigger of the 2 denominators. So this tells me that my major axis is going to be the y-axis because the bigger number is under the y squared. Always remember that your a squared is always bigger than b squared. So 64 is greater than 16. So my graph here, my major axis is y. So we could also say that it's vertical. Next thing we need to do is calculate the vertices, the co-vertices, and the foci. So I'm going to first calculate my vertices. Again, remember the vertices come from the a squared. So I'm going to set a squared. So right now, my equation is taking on this form. X squared, and it's got the smaller number under it. It's got the 16, so that's your b squared. And then the bigger number is the 64, which is under, it's the a squared, which is under the y squared. So a squared, which is the 64, it's under the y. I'm going to solve for a by square rooting both sides, and a is equal to plus and minus 8. I'm also going to solve for b. So b squared is equal to 16, square root it, and b is equal to plus and minus 4. Now, our origin is the center of our ellipse. I need to calculate my vertices and my co-vertices. Again, vertices come from A, so I'm going to take and create my vertices. It's going to be the order pair 0, 8 and 0, -8, because remember your major axis is vertical. So I'm adding this A value to the y of my vertex. So right here, this is going to be 0, 8. Down here, 0, -8. And these are the vertices. For the co-vertices, these are along the x-axis because this is my minor axis. So this will be my minor. This is my major. And now to get the co-vertices, I'm now going to add the 4 and subtract the 4 to the x. So it's going to become the order pair 0, -4, 0, and 4, 0. And these are co-vertices. So this is the vertice. And over here is a vertice. These are the co-vertices. Let's do them in red. Co-vertices. I'm going to go ahead and connect the red and the blue dots and create my ellipse shape. And I need to make it kind of circular, actually ovalish. And and this is my ellipse. Now I also need to calculate the focus point. Now for the focus point, it's sort of like Pythagorean theorem, and the equation we're going to use, because we're going to determine the focus, we're going to call it C. Okay, so again, we're going to calculate the focus, and we're going to use this equation. C squared equals A squared minus B squared. So C squared, remember your A squared was 64, B squared was 16. C squared equals 48. I'm going to simplify this radical because remember we're square rooting both sides to get C. So this becomes plus and minus the square root of 48. I need to break down the square root of 48. I could break it down into 16 times 3, which becomes 4 radical 3. So now my focus point, again, remember it's on the major axis. So we're adding this to the y because your major axis was the y-axis. So the focus points become 0, comma, plus and minus 4 radical 3. I can split it apart, positive 4 radical 3 and negative 4 radical 3. Now, what I'm going to do here is I'm going to approximate this. Now, I know you guys are going to have your calculator, so you could get, a better idea. You could use the square root of 3 times 4. But if we were doing this in the classroom, we wouldn't be using our calculator. We would approximate the square root of 3. It's in between these two perfect squares. So I'm going to say that the square root of 3 is probably about 1.7. So when I go to do this and I go to graph this, I'm not looking for exact. It would be 4 times 1.7. So I'm going to graph my focus a little bit past the halfway point. So a little bit past halfway between 0 and 8, a little bit more than 4. So I'll put my focus points here. And again, you can just label them with the radicals. So you could say that this is 0, comma, 4 radical 3, and then this one's 0, comma, negative 4 radical 3. Again, you can just do this on your calculator, and you can see exactly where to graph this focus point. So that would be what you're looking for. So again, when you're doing the homework, you're going to be asked to find the focus points, the vertices, the co-vertices, and then you're going to be asked to graph. You're also going to be asked for the domain and the range. So we're going to write it in the interval notation. So remember, domain is x, so I can see that it goes from negative 4 to positive 4. And the range goes from, it's the y, top to bottom. So my range, the lowest it gets is going to be negative 8, and the highest it gets is positive 8 up here. Let's try the next one. Again, remember you want your equation set equal to 1. So what I need to do here, again, my center's still at the origin, so I need to divide everything by 36. I can reduce 4 over 36. This becomes x squared over 9. I can reduce 9 36, and this becomes y squared over 4, and then it equals 1. So this time I can see that my major axis, my bigger number here, is under the x squared. So my major axis is the x-axis because my bigger number's under the x squared. So this is going to be a horizontal ellipsis. So now I need to find my vertices and my co-vertices. So remember, vertices come from the a squared, and this is set up like this, x squared this is the setup for this one, because the bigger number is under the x squared, so that's where my a squared is. So a squared equals 9, square root both sides. A is equal to plus and minus 3. Do the same thing for the b. B squared equals 4, square root it. B is equal to plus and minus 2. So now we're going to come up with our vertices. So remember, your major axis is the x-axis, so we're going to add and subtract this 3 to the x of the origin, or the center. So my vertices, this is my center point. I'm going to take that plus and minus 3, and it goes to the major axis variable, which is x. So my vertices are going to occur at -3, 0, and 3, 0. My co-vertices, I'm going to take this 2, and it's going to be added and subtracted to the y of the center. So this will become 0, -2, 0, 2. So let's go ahead and label these. So I have one here and here. So 0, 2, this is a co-vertice. 0, -2, another co-vertice. And now the vertices are at -3, 0. And I'm going to put another tick mark here. +3, 0. Those are the vertices. Again, I can connect these red and blue dots and make my oval shape, which is the ellipse. I now need to calculate the focus. So we're using c squared equals a squared minus b squared. C squared equals, my a squared is 9, my b squared is 4, c squared equals 5, square root both sides, c is equal to plus and minus the square root of 5. I don't need to break it down, it's already in simplest radical form. Now again, to approximate the square root of 5, it's in between these two perfect squares, closer to the 4, so I'm going to say the square root of 5 is about 2.2. So this is what I'm going to be graphing. So my focus points are going to be -√5, 0, and +√5, 0. And again, I'm going to put these on my graph, so about here and here. So you can say this is -√5, 0, and you can say this one is √5, 0. And these are the focus points. Domain. So for my x value, because domain is always x, it goes from -3 to +3. For the range, that's the y, and it goes from -2 to +2. So again, it's going to ask you to list vertices, co-vertices, focus points. It's going to ask you to graph it, and then also give domain and range. Now, all of these examples had the center at 0, 0, at the origin. Now we're going to shift our center to a different order pair. So here, notice just like before with the parabola, the center, the order pair we're going to call it, is h and k. So again, the x of the center and the y of the center. So the x of the center is h, the y of the center in that order pair is k. So again, when your a squared is under, your a squared is always going to be the bigger number. So when it's under the x minus h squared, you know you have a horizontal ellipsis. When your a squared is under the y, then it's said to be vertical. Let's try an example. Now, for this one, it's already set equal to 1. So now the first thing I need to determine is which number is bigger, 9 or 16. I can see that the 16 is the bigger number. So this tells me that my y-axis is going to be the major. or you could say that it's vertical. So let's go ahead and calculate the vertices. So a squared equals 16. Square root it, a equals plus and minus 4. B squared equals 9. Square root it, plus and minus 3. Now, before, we also need to pull out our h and k. So remember, h is always with x, k is always with y. So my center of my ellipse is going to be at the order pair 2, -1. Again, remember those subtraction signs are part of the formula, so it's backwards of what you would think. So now, before my center was at 0, 0. So when I calculated this a and b value, I was adding it to a 0. But now I'm actually going to add it to this point. So for my vertices, remember you're going to add and subtract this 4 to the major axis variable, which is the y. So I'm really going to be doing 2, and then here is my center, so -1, and to that -1 I'm going to both add and subtract the 4. So my first order pair, when I do -1 plus 4, I get 2, 3. When I do -1 minus 4, my other vertex is at 2, -5. So let me graph both of those and my center point. So let me graph my center. It's at 2, -1. I'm going to graph my vertex. It's at 2 and 3. And then the other one is at 2 and -5. And I didn't do that right. Let me erase this one. 2 and 3 is up here. Let me do this in blue. And then 2, -5, 1, 2, 3, 4, 5 is over here. So these are the ends of my major axis. And now I'm going to do the same thing for the minor axis and get my co-vertices. Notice before I added and subtracted the 4 to the y, now I'm going to subtract this 3, add and subtract the 3 to the x of the vertice. So I'm going to add and subtract 3, and then this time the -1's going to stay. So my co-vertices are going to be first 2 minus 3, so that gives me -1, -1. And then over here, I'm going to do 2 plus 3, so I would get 5, -1. So let me graph both of those. So -1, -1 is here. And then +5, 1, 2, 3, 4, 5, and -1 is there. So now I can connect my red and blue dots and make my ellipsis shape. Now I need to calculate the focus. C squared equals a squared minus b squared. C squared, 16 minus 9. C squared equals 7. C equals plus and minus root 7. Again, I could approximate the square root of 7. This would be a 2, this would be a 3. So the square root of 7, it's like halfway in between, maybe a little bit more than halfway, so about 2.6. So when I go to graph this, I'll have a better idea of where my point's going. So remember, for your focus point, it's always on the major axis. So again, you need to work with the center point. And again, since it's on the major axis and my major axis is y, I'm adding and subtracting root 7 to the y of the center point. So I'm going to end up with 2, -1 root 7 plus root 7, and then that'll be 1, and 2, -1 minus root 7. So this 1, -1 plus root 7, this is probably about 1.6. And then over here, -1 minus root 7, which is about 2.6. It's about -3.6. So again, let me go ahead and add in the focus points. So I'll say here about -2, -3, so about here. And then -1, and then 1.6. And those would be your focus points. Again, you could just label, so what I would do here, let's label the center in green. So my center is that point, and then the 2 black dots, I could say that this is 2, and this bottom one is -1 minus root 7, and this one is -1 plus root 7. And these are both the focus points. Domain, it's going from -1 to +5. Range, -5 to +3. Let's try another example. This time I need to fix it. Remember, this needs to be a 1. So I need to divide everything by 16. So times 16 times 16. So I get x plus 3 squared over 64. Y minus 3 squared over 16 equals 1. I'm looking for the bigger number. My bigger number is the 64. So this tells me my major axis is going to be the x-axis. So this is horizontal. So now, again, what we need to do is find the center. So I'm pulling out my HK. So my center point is going to be -3, +3. This is the center. I need to find the vertices. So I need to figure out what A equals, because I need to add that to the X. So A squared equals 64, square root it, plus and minus 8. B squared equals 16, square root it, plus and minus 4. So now to find, so this would be for your co-vertices. So now to find your vertices, we're taking the center point, which is -3, +3, and to get our vertices, we're going to be adding and subtracting the 8 to the x, which was our major. So I'm going to be doing -3 minus 8, so that'll give me -11, 3. And then I'm going to do -3 plus 8, so I would get 5, 3. These are my vertices. For my co-vertices, I'm still working with this center point, but this time I'm going to add and subtract the 4 to the y of the center. So my co-vertices, I'm going to get -3, and then the first one I'm going to do 3 minus 4, so I get -1. And then I'll do the 3 plus 4, so then I get -3 plus 7. These are co-vertices. Now I need to graph these 4 points. So let me go ahead and graph the -3, -1. I'm going to graph -3, +7. 1, 2, 3, 4, 5, 6, 7. So up here. Let me also graph my center. Do that one in green. -3, 1, 2, 3, +3. now need to do the co-vertices. 1, 2, 3, 4, 5, and 3. And then 11, negative 11, comma 3. And it'll come here. Connect the red and blue dots. Make it oval in shape. That's your ellipse. I now need to calculate the focus. C squared equals A squared minus B squared. A squared is 64, B squared is 16. C squared equals 48. Again, we already broke this one down, so plus and minus 4 root 3. Now, I need to create and turn it into order pairs. Again, I'm working with my center. Remember, the focus is always on the major axis. My major axis was X, so I'm going to be adding 4 root 3 and subtracting 4 root 3 to the X of my center. So I'm going to be doing negative 3 minus 4 root 3. So then this order pair, and I could leave it like that, so negative 3 because they don't have radicals. And then the other one would be negative 3 plus 4 radical 3, comma 3. Now, again, we could approximate this. We said this was about 2.6 or 1.6. So I'm just going to do this on my calculator. And negative 3 minus 4 radical 3 is about negative 9.9, comma 3. And then here, when I do negative 3 plus 4 radical 3, I get 3.9, comma 3. So let me graph both of these. So almost to the 4, 1, 2, 3, 4. So I'll put my focus there. And then almost to negative 10, 1, 2, 3. Well, it's just before here, so here. So these will be your 2 focus points. And again, you can label them. So the focus points are going to be negative 3 plus and minus. I'll just do shortcut here. So those are your 2 focus points. Notice I just put it with the plus minus. So domain goes from negative 11 to 5. Range goes from negative 1 to positive 7. So you should be finding domain and range. You should be finding your vertices. You should be finding your co-vertices. And you should be finding your 2 focus points and your center. So you have to find all of those parts of the ellipse. Your homework for this, due Friday, is 3 through 14 all. Again, I've included the answers for the evens so you can check them. This is due on Friday.